Imagine for a moment that what we see in the universe might not always be the truth. The starlight we gaze upon could be distorted, bent by a mysterious energy, invisible to the naked eye. And sometimes that distortion creates something breathtakingly beautiful, like a piece of cosmic art. Scientists call it an Einstein Ring. This phenomenon isn't just a wonder of physics, it's a vital key to unlocking the secrets of the universe, from dark matter to dark energy. Today, we're going to dive deep into the story of these rings of distorted truth. Get ready, because what you're about to hear will change the way you look at the universe forever. Welcome to our channel, where we explore the mysteries and wonders of the cosmos. We're talking about an astronomical phenomenon that is both stunning and incredibly significant, the Einstein Ring. The name might sound complex, but I promise you, the story behind it is just as fascinating as the name itself. An Einstein Ring is a cosmic illusion that occurs when light from a distant galaxy travels past a massive object in its path, like a large galaxy or a cluster of galaxies. This massive object acts like a giant lens, bending the light into a perfect ring right around itself. This isn't just a pretty picture, it's powerful evidence that confirms Albert Einstein's general theory of relativity. And it's also a crucial tool that helps scientists see things that are far beyond our normal reach. Over the decades, astronomers have discovered many Einstein rings, each telling its own unique story. And recently, the European Space Agency's Euclid Space Telescope caused a major stir by discovering a perfect Einstein ring that is closer to us than any we've ever seen before. This discovery doesn't just reinforce our understanding of the universe, it opens the door to solving some of the greatest mysteries of the cosmos: dark matter and dark energy. In this video, we'll take you through the history of this concept, from the birth of general relativity to Euclid's incredible discovery. We'll explore how Einstein rings are formed, why they matter to science, and most importantly, what this phenomenon tells us about the nature of reality and the philosophy we can learn from it. Get ready for an eye-opening journey into the heart of a phenomenon the universe uses as a mirror to reflect its deepest truths. Before we can truly understand the Einstein ring, we need to go back to its roots, the general theory of relativity, which Albert Einstein introduced in 1915. This theory revolutionized our understanding of gravity. Instead of seeing gravity as just a pull between masses, Einstein proposed that gravity is the result of the warping of space-time, a four-dimensional fabric that weaves together the three dimensions of space and the one dimension of time. Imagine a tightly stretched sheet. When you place a bowling ball in the center, the sheet curves downward. If you roll a small marble near the bowling ball, the marble will curve toward it, not because of a direct pull, but because the sheet itself is warped. In the same way, massive objects in the universe, like our sun, stars, or galaxies, warp the space-time around them. And this warping affects the path of everything moving through it, including light. This is the key point. Einstein predicted that light, which was once thought to always travel in a straight line, must bend when it passes near a massive object. This phenomenon is called the gravitational deflection of light, or more broadly, gravitational lensing. This idea was first proven in 1919 by the British astronomer Sir Arthur Eddington. During a total solar eclipse, he observed that the positions of stars near the Sun shifted slightly from their normal spots, exactly as Einstein had predicted. This discovery made Einstein a global celebrity, and the general theory of relativity became widely accepted. Once we understand that gravity can bend light, the concept of gravitational lensing becomes much easier to grasp. Think of a glass lens we use to look at small objects. That lens gathers light and magnifies the image for us. The universe works the same way. Massive objects, like galaxies or galaxy clusters, can act as a gravitational lens, bending light from a distant object and making it appear to us in a different way. Gravitational lensing comes in several forms, depending on the position, mass, and alignment of the lens and the light source. Weak lensing happens when the bending of light is subtle, causing the background galaxy's image to be only slightly distorted. Astronomers use these tiny distortions to map out the distribution of dark matter in the universe. Strong lensing occurs when the bending of light is significant, creating images that are magnified, clearly distorted, or even creating multiple images of the same source. And this is where our topic today comes in, the Einstein Ring. So, how does an Einstein ring form, and why is it so remarkable? An Einstein ring is the rarest and most beautiful form of strong gravitational lensing. It happens when three conditions align perfectly. First, a distant light source, usually a galaxy billions of light years away. Second, a gravitational lens, a massive object between the source and us, often a large galaxy or cluster closer to home. And third, perfect alignment, the source, the lens, and the observer, that's us, must be in a perfectly straight line. When these three conditions meet, light from that distant galaxy is bent all the way around the gravitational lens, making the image of that galaxy appear as a perfect ring surrounding the lens object. Instead of seeing a small point of light or several distorted images, we see a magnificent circle of light. This is what makes an Einstein ring so special. It's the most perfect visual representation of the warping of space-time. The width of an Einstein ring depends on the mass of the lens and the distance between the three objects. The more massive the lens, the larger the ring. By studying the size and shape of these rings, scientists can calculate the mass of the lens, even if that object is invisible to us. And this is where the Einstein ring becomes a powerful tool for studying dark matter. Now, for one of the most exciting parts of this story, the role of Einstein rings in solving the two biggest puzzles of the universe, dark matter and dark energy. These two make up most of the cosmos, yet we can't see them, and we still don't fully understand their true nature. Dark matter is a mysterious substance that doesn't interact with light. It doesn't absorb, reflect, or emit it. So we can't see it directly, but we know it's there because we see its gravitational effects. Galaxies rotate too fast for the visible matter to explain. Galaxy clusters have more mass than they should, and the large-scale structure of the universe couldn't have formed without dark matter holding it all together. Einstein rings are an incredible tool for studying dark matter, because the bending of light that creates the ring isn't just caused by the visible matter in the lens galaxy. It's also caused by the mass of the dark matter within it. By carefully analyzing the shape and size of the ring, scientists can calculate the amount of dark matter hidden in the lens galaxy. This is one of the only ways we can weigh dark matter indirectly and understand how it's distributed across the universe. Then there's dark energy, a mystery just as deep. It's a mysterious energy believed to be causing the expansion of the universe to accelerate, which contradicts the old idea that gravity should be slowing it down. While Einstein rings don't detect dark energy directly, studying gravitational lensing as a whole, especially the distribution of galaxies and clusters across the vast universe, can provide insights into the expansion rate of the cosmos. It helps scientists build better models to explain the role of dark energy. In other words, Einstein rings are like a large window, allowing us to see the influence of the invisible and understand the fundamental building blocks of the universe we live in. In the world of astronomy, new discoveries always bring excitement, and recently, the Euclid Space Telescope from the European Space Agency made headlines around the world with the discovery of one of the most perfect and stunning Einstein rings ever found. This discovery doesn't just highlight Euclid's incredible capabilities, it reveals secrets of a galaxy we thought we already knew well. Euclid was launched into space on July 1, 2023, with a primary mission to explore the dark universe and create the largest 3D map of the cosmos. It observes billions of galaxies, up to 10 billion light-years away. During its early testing phase in September 2023, Bruno Altieri, a scientist at the Euclid Archive, noticed something unusual in a low-resolution image. When Euclid observed that area again with higher resolution, the image that appeared left everyone in awe. What Euclid found was a perfect Einstein ring surrounding the galaxy NGC 6505. This galaxy is only about 590 million light-years from Earth. In astronomical terms, that's very close. What's amazing is that NGC 6505 has been known to astronomers since 1884, but no one had ever noticed the Einstein ring surrounding it before. This shows the power and precision of Euclid's instruments, revealing new things even in places we thought we knew well. The ring seen around NGC 6505 is actually light from another galaxy much further away, about 442 billion light-years out. The light from this background galaxy was distorted by the gravity of NGC 6505, creating a beautiful and perfect ring. This distant source galaxy had never been observed before and doesn't even have a name yet. This discovery is incredibly significant because it's the closest strong gravitational lens to Earth ever found, and its perfect alignment makes it a perfect natural laboratory for studying gravity, dark matter, and dark energy. Conor O'Riordan, from the Max Planck Institute for Astrophysics and lead author of the first scientific paper analyzing this ring, said, "All strong gravitational lenses are special because they are so rare and incredibly useful for science. This ring is especially special because it's so close to Earth, and the alignment makes it so beautiful. This discovery is a great sign for the Euclid mission, which is expected to find about 100,000 strong gravitational lenses over its lifetime. But finding such a stunning ring so close to home, so early in the mission, is truly extraordinary. Beyond the beauty and excitement of the discovery, Einstein rings are invaluable scientific tools. They allow astronomers to study phenomena and objects in the universe that wouldn't be possible any other way. First, studying the expansion of the universe. Einstein rings can be used as cosmic clocks. When light from a source reaches us through two different paths, one through the center of the lens and another through the outer edge, the two paths take different amounts of time. This time difference can be used to calculate the expansion rate of the universe, which is vital data for understanding the future of the cosmos. Second, seeing distant galaxies. Gravitational lensing acts like a massive natural telescope. It magnifies light from galaxies that are so far away and faint that we couldn't see them with normal telescopes. Einstein rings help astronomers study the formation and evolution of galaxies in the early universe, a time when the universe was young and very different from today. Third, mapping dark matter. As mentioned, analyzing the shape and size of an Einstein ring helps scientists map the distribution of dark matter in the lens galaxy. This is a key way to understand the nature of this mysterious substance, which makes up most of the mass in the universe. And fourth, searching for exoplanets. Although very rare, small gravitational lenses caused by single stars can create a phenomenon called microlensing. If the lens star has a planet orbiting it, it might cause tiny changes in the brightness of the magnified light. which can be used as a way to detect planets outside our solar system. Beyond its scientific importance, the Einstein Ring offers deep philosophical insights, inviting us to reflect on the nature of reality and perception, seeing the invisible. Einstein rings help us see what is otherwise hidden, like dark matter. It reminds us that, in our own lives, the most important things might not always be what we see with our naked eyes. Love, hope, dreams, or even fear are all invisible. Yet they influence our lives profoundly. Learning to see the invisible, or understanding what lies behind various phenomena, is a vital skill for living. Time travel. Light from distant galaxies travels for billions of light years before reaching Earth. When we look at an Einstein ring, we are looking into the distant past of the universe. It reminds us that we are just a small part of the vast history of the cosmos, and everything we see is the result of events that happened in the past. Realizing the greatness of time helps us value the present and understand that we are part of a story much larger than ourselves. An Einstein ring isn't just a beautiful illusion in the sky, it's a powerful tool that helps scientists unlock the mysteries of the universe. It's evidence of Albert Einstein's genius and a window that allows us to see the distant and the invisible.